Hello and welcome back. So in our previous segment, we were talking about the energy that is absorbed by electrons when they jump an energy level, and then the energy that is emitted when they come back down, and then that energy is going to be proportional to the frequency of the light that they emit. So let's take a look, for example, at hydrogen. So hydrogen is as simple as you get because it's only got one electron. And so you can see that if that electron makes a jump from energy level 3 to energy level 2, it's going to give off a certain frequency of light which corresponds to the color red. But if it makes the jump, let's say, going from energy level 6 to energy level 2, that's going to be more energy when it makes its jump. And so that's going to correspond to a higher frequency, which is going to be, let's say, the color purple. So those are the allowed jumps for the electron in the hydrogen. And those are the four colors of visible light that are being produced. Now so you see off there to the side, that's the spectrum of hydrogen. It's got a red line, it's got a bluish green, it's got a blue one, and then it's got a purple one. And then that's where those colors are coming from. Do you notice it also has a lot of black? So what's the significance of the black part of the spectrum? Those represent forbidden jumps. Do you remember when we said that you got energy level here and one up here so that the electron could jump as long as it's jumping from one energy level to the next? But it can't jump halfway. That would be a forbidden jump. So the black part there represents frequencies of light that you don't see because they would be forbidden jumps for that particular element. So how do we see those colors? If you were to look at a hydrogen that's been excited, you don't see those colors. So what you're going to see is actually a pinkish color. So in that, what we do is we put the gas into a glass tube, and then we electrify the glass tube so that those electrons are jumping up and down, and they're emitting all of those different colors. So they're emitting the red, the bluish green, the blue, and the purple. When you put that all together, you get the color pink. So how do we separate it into its individual colors? Well, that's where you could use a prism, so that would do it. That separates light into its component wavelengths. But a better way is by using a diffraction grating. And so a diffraction grating is a little piece of plastic, and on that piece of plastic are thousands of scratches, kind of like a picket fence. And then when light goes through those little scratches, it spreads out. Diffraction. So that's why we call it a diffraction grating. It takes the light, it spreads it out when it goes through those little doorways. We talked about what diffraction was when we mentioned how light can be reflected, refracted, and then we talked about diffraction. So this is going to be diffraction. It's spreading out the light, and then you can then see those individual colors that make it up. Well, you have all sorts of different elements, and every element has its own unique set of colors. So up at the top is the hydrogen, and you can see it's the colors that it emits. And then you can see the sodium, and you can see the helium, and then the neon, and then the mercury, and every one of those elements has a unique set of colors because they have a unique set of electrons, And then those electrons, they also interact with each other to change the energy levels. So if you want to see the spectrums of the different elements, then go to that website, and then you can put the cursor on a particular element, and then it will display the other spectrums for you. And then here is all of the spectrums for every element in the periodic table, just so that you can see that they look different. Okay, in our next segment, well, let's do this. I also wanted to show you other kinds of light can be emitted. It doesn't just have to be visible light. So you see there's the 4 colors for hydrogen, and you can see the jumps that produce those 4 colors. But there are other kinds of jumps that can be made, and when the electrons make those jumps, can you see that hydrogen can also produce infrared light, and it can also produce ultraviolet light. So we're not interested in that. We're just interested in the visible part of the spectrum. But I just wanted you to see that atoms can also produce other kinds of light other than just the visible part. So in our next segment, we're going to talk about 2 other kinds of spectrums. See you then.